Good morning, students. Today we are going to start with discrete time system. In the last lecture, we already have gone through different operations on discrete time system, where we have seen time shifting property, or time shifting operation, time scaling operation, and amplitude scaling operation. All those particular operations we already have understood by making some graphical representation, because the thing is, when you are looking for any signal graphically, you will be understand that particular operations very clearly. Because as I already have discussed, that when you are going to deal with a discrete time, all those particular discrete signal are actually defined with a number of samples. So whenever it comes to any applications, any operations on that particular signal, all those particular operations are actually done by using sample wise. So if we are going to talking about addition and multiplication, that is also going to be done by sample wise. Something like zeroth sample is only going to be added or multiplied with the zeroth sample. In order to making these particular operations happen, and it was a condition was that whatever two particular signal you wanted to add, both having the same length of number of samples, or same length of sequence. And if not, then we need to add some number of zeros at the right side or left side to make a same length of both the sequence. And that is why we are padded some number of zeros either at the right side or the left side. And ultimately that particular process of adding some number of zeros is known as zero padding. So all in all, whatever we have seen in a last lecture was only the operations which is going to be applied on discrete time signals. So we had started with this particular chapter as signals and system, where initially we started with different types of signals, where signals are going to be considering as a classifications of different types, where we had started with the continuous and discrete type signal, continuous valued and discrete valued, even and odd signal, periodic and non-periodic signal, deterministic and random signal, multi-channel and multi-dimensional signal, and etc. So there are multiple categories and multiple classification of a different types of signal. Then we have seen some standard signal which is going to be actually useful for academic purpose, something like unit step, unit impulse, unit ramp, and exponential. Then we have seen some special types of signals as well, called a signum function, rectangular function, sinc functions, and all. So all in all, the point I would like to make over here is when we are going to dealing with the signals and systems, different types of signal with all its characteristics we already have gone through. So now you are in a conditions to identify different types of signal at any characteristics with it. So when you are going to dealing with a signal, you must understand how this particular signal is graphically represented, how it is going to be defined mathematically, and if we would like to apply any operation on that particular signal, what should be the procedure. So all the part of a signal side is already done. Now we are going to start with system, and that is why the first topic today we are going to taking is discrete time system. Now we are dealing with a system, and as we already know, in a fourth semester for a control system, we already have discussed a word called system. A system itself a word where this particular block diagram is most important. That any system is going to be initially taking something as an input, and that particular input is nothing more than a signal, and that is why we have already studied all the different types of signal and its characteristics. So whatever the signal we have already studied, those signals will be applied as an input to the system, and inside the system, and obviously that particular system is a discrete time signal, we are going to apply somewhat of a different process on it. So we are taking input as an excitation, and all those particular input we have already gone through. On this particular signal, we are apply the processing, and after a successfully applying a process, we are actually getting somewhat of output. In a technical term, it will be considering as a response. So those particular response we will be getting, but the thing is what, it depends upon what type of process we are going to be applied. And those whole process, a combinations of input, output, and process is combinedly considering as a discrete time signal. So if you are going to look at to the screen, it can be actually defined as a physical device which performs a required operation or a discrete time signal. So actually, as I told you, when we are going to define a system, we should be very clear about the output or a response. What type of output we want as in response from a system. Based on that, we need to apply the input signal, and based on that again, we need to apply the process as well. सो कौन से टाइप का प्रोसेस हमें कौन से टाइप के सिग्नल पे करना है, दैट्स प्योरली डिपेंड्स अपॉन व्हाट टाइप ऑफ आउटपुट वी वांट, right? So basically if you are going to look at to a system, it is nothing more than a physical device. If we are talking about a device, a real time example is nothing more than a mobile. A mobile itself a device, mobile itself a system, where our audio signal will be goes as an input. On that particular audio signal, somewhat of process is going to be applied inside a process, and that is going to be transmitted from this particular mobile to another mobile and received at the receiver side. So the thing is, system is nothing more than any physical device which taking somewhat of signal as an input. On that particular input signal we are apply the process, and after application of process, this is going to be received at the receiver side as a response. So if you are going to look at to this particular block diagram, it is quite simple. X of n will be considering as an input. In a technical term, it can be understand as an excitation. This will be given to a discrete time system, and on a discrete time system, we are going to apply different process in order to getting what type of output we will be having. So after applying a processing, we will be getting somewhat of output as yn, and that y of n will be considering as an output, and in a technical term, that will be considering as a response, right? So the mathematical notation, if you can understand, it can be defined as what, x of n, then a simple arrow, and on the arrow a t is going to be defined. So that particular t is actually used for a transformation operation. Now transformation is nothing more than what type of process we are applying. So transformation is nothing but the whole process, or which is going to be applied on a system. So if you are going to look at to this particular mathematical equation, it can be defined as what, x of n, which is going to be written at the left side, will be considering as an input. On the input, somewhat of transformation process is applied, a transformation operation is going to be applied, and after transformation process, we will be getting y of n as an output. So this symbolic representation, the mathematical representation with the arrow, and on the arrow it is going to be written as a t, defined as a transformation operation. Or in a similar way, if we would like to define mathematically into some another way, it can also be defined as y of n is equal to capital T into a bracket x of n. So if we are going to simply understand it, it can be defined as y of n at the left side, which is going to be comes as an output. So this output y of n will be coming from applying transformation on input signal x of n. You understand? See, x of n is in a bracket, and out of the bracket, this is a capital T, which is going to be useful to understand a transformation operation. So all in all, it is going to be quite simple to understand mathematically that y of n is equal to t of x of n, where t actually considering as a transformation operation. Now keep in mind this notation is most important because when we are going to dealing with somewhat of system mathematically. So there are multiple ways to define a system mathematically. Out of these two, any can be used to define a system in terms of mathematical operation. Basically, this particular second option is going to be mostly useful to identify what type of system it is and how it is going to be mathematically identified. So it is quite simple. Capital T is a transformation operation which is going to be applied on x of n, and after application of transformation on x of n, you will be getting output as in y of n. So all in all, you can define mathematically a discrete time system is y of n is equal to 2 into x of n. Now, the point I would like to make over here is I am going to make you aware about all the notations, because this is not going to be asked in examinations, but the important thing is you need to understand the notations from the mathematical point of view. Because when we are going to be dealing with the different types of example at that particular time, they are going to define a mathematical symbolic representation to define system and signals, and that is why this is most important, how you are going to be identified, how you are going to recognize this particular notation is useful for which particular system. You understand? Our next topic or our next part is when we are going to define or represent a discrete time systems, we will be having a multiple types of symbol. Now this is actually considering as a graphical representation. When we are going to graphically represent any mathematical model of a system, there are some certain symbols which is going to be useful to represent the system. So out of those, we are having a list of different types of symbols. Out of those, a first symbol is adder. We will be having a look into a detail how adder is going to be defined, what type of symbol we are going to be used, and if this particular type of symbol will comes in a system, what is the significance, what is the importance of this comes in a system, and how it is going to be operating the whole process that we are going to see. So now here I am going to making a list of different types of symbols. So out of those, first is adder. Second is a constant multiplier. So if I would like to multiply any constant values with the signal, that will be considering as a constant multiplier. Second is signal multiplier. When we are having a two different signal and we would like to go for a multiplication, considering as a signal multiplier. All these having its own different type of symbols. We'll be having a quick look on these after this particular slide. Next is unit delay. We already have gone through a time shifting property where delay is going to be applied on a signal. When a unit delay, unit means we know that unit having nothing but the value 1. So when we are having a delay of one sample considering as a unit delay, and how this particular unit delay can be graphically represented by using some symbolic representation, we will be having a look on that. Next is unit advance. So these are the five major processes which is going to be useful to represent a discrete time signal. And for each individual processing, we will be having an each individual symbols as well. So let us start with the first one. As we have listed down a different type of processor, out of those, adder is the first one. So it is quite logical and understandable that it is going to be useful to perform an addition of two input sequence. So when we will be having two input signal in a image, you can see in a graph, you can see this is x1 is the first signal, x2 that is the second signal. Two particular signals we will be having, both are not down, both are time discrete time signals. So x1 of n and x2 of n both are discrete time signal, and if we would like to add both the signals, we are going to use a simple symbol called adder something here. So you can see these two arrows of x1 and x2 is going to be given to this particular symbol, a plus sign into a circle, considering as an adder symbol. So after addition of two particular signal x1 and x2, ultimately you will be getting an output called y of n. So y of n is equal to x1n plus x2n. So it is quite logical. So whenever we are going to define any particular system, and in a system, if you can see such type of symbol, keep in mind those particular symbol, which is going to be looks like this, will be considering as an adder signal. And adder signal can be used for addition of two different input signal. So the final output can be defined as y of n equal to x1 of n plus x2 of n. Simple. Next, now, if you would like to apply the subtraction process, so we do not have any, a particular individual symbol for a subtraction. Ultimately, it is an addition. But when we are going for an addition with the negative signal, and now you need to understand over here, negative signal is nothing more than a folded signal. You understand, right? So when we are having x1 of n over here is a positive signal, will be adding to the positive, adder, and x2 of n with a negative sign over here just beside this, below this. So x2 of signal having a multiplication with minus 1. You understand in this way also. So basically we are going to add this signal, but when we are going to adding this particular signal, second signal will be into a negative form. So that is why all in all you can writing down these into equation mode as x1 of n minus x2 of n. So ultimately by using adder symbol you can go for n subtraction operation. So note down, we do not having any symbol which is going to be useful for a subtraction process. Otherwise some people may understand that in place of this particular plus they are going to be replaced with the minus, and they may be use this particular symbol as a subtractor. But no, in a time discrete time signal we do not having any subtractor operation or subtractor signal, it is only adder. But if you would like to go for in a subtraction process, you just have to multiply second signal with the negative sign, and you can add a negative signal with the positive. So all in all, it will be coming as the same one, y of n equal to x1 of n minus x2 of n. Right? Next. Next as a constant multiplier. As I told you, when we are having one particular signal called x of n, and if I would like to multiply any constant value, something like a over here, you can see this. So whenever a is going to be multiplying with x of n, now a is nothing more than any amplitude value. You may use a is equal to 2, 5, 10, 15, whatever. So that particular constant multiplier can be denoted as a symbol into a signal. So x of n is the input over here. Whatever we would like to multiply as a constant, that can be shown by the arrow over here, and on the arrow you have to multiply, shown that particular variable's value. In place of a, if you are going to writing down 5, the meaning of this is what 5 is going to be multiplying with x of n, and after doing that you will be getting y of n is equal to a into x of n. So this is called a constant multiplier. The name itself suggests that we are going to multiplying a constant value with the input signal. So the finally output y of n can be defined as what? A into x of n. Now you need to understand a difference between constant multiplier and a signal multiplier. So next is a signal multiplier. So keep in mind, signal multiplier is basically useful for a multiplying two different sequence. This is same as an adder, where we are going to add it two particular different input signals. Here we are going to use adder over multiplier over here for a multiplication of two different signals. So you can understand x1 of n is an independent signal, x2 of n is an independent signal. Both is going to be given to this particular symbol called multiplier, where in a circle we will be having a sign of multiplication. So both independent signal can be multiplying, and as an output y of n can be defined as what? X1 of n into x2 of n. Quite logical. Then we will be having a unit delay. Now this unit delay is basically useful to show or to apply the delay in an input sequence by one sample. Keep in mind, this particular input signal or this particular symbol is only for unit delay. So x of n we will be having, and if I would like to apply a delay of one sample, that symbol can be defined as what? Z raised to minus 1, where z is a symbol for z raised to minus 1 is a symbol for unit delay. And keep in mind, unit means we will be having a delay of one sample. So x of n was the original signal, उसमें हमने एक sample का delay दिया. So obviously y of n can be defined as what? X of n minus 1. So now the question comes over here is what? Okay, when we are having a delay of five samples or two samples, then what? That naturally in everyone's mind that might comes in your thought that if I would like to apply a delay of two sample or five sample, that should be written as z raised to minus 2 or z raised to minus 5. But no, if we would like to apply multiple delays over here, something like if I would like to apply a delay of two samples, just look at 2 seconds image. If we would like to apply a delay of two samples, we need to apply a two blocks consecutively, which is going to be connected in a series. So you have to keep in mind z raised to minus 1 in this particular square is the symbol for unit delay. We cannot apply a multiple delays at the same time. Something like z raised to 5 हमने लिख दिया, तो उसका मतलब ये नहीं हुआ कि हमें 5 सैंपल का डिले मिल गया. If I would like to show a 5 samples delay, I have to connect this particular 5 blocks in a series. Then and then you will be able to getting a total delay of 5 samples, and that is why this specifically symbols name itself are known as what? Unit delay. क्योंकि सिंबल ही इस तरह से डिजाइन किया है कि हमें उसमें यूनिट डिले ही मिलेगा. देयर विल बी अ डिले ऑफ वन सैंपल्स ओनली. So if you would like to apply a multiple samples delay, that many numbers of unit delay symbols you have to connect in a consecutive way, in a series way. So if would like to show a delay of two samples, we have to connect two individual square of a unit delay into a series. So x of n was the original signal. We are going to apply the first delay. So after applying the first delay symbol, you will be getting output as an x of n minus 1. Now in x of n minus 1, you are going to apply the second delay. Second unit delay means what? Again in this particular signal, we will be having a delay of one more sample. So the final output y of n can be defined as x of n minus 2. So I think I am making it clear that if how many numbers of delay you would like to apply in terms of samples, that many numbers of blocks you have to connect in a series, right? And that is why this particular symbol is known as what? Unit. Now similar way in case of unit advance, this particular symbol is basically for unit advance. In a unit delay, you are going to identify this particular signal with the minus sign, because we already have gone through that delay signal or a delay operation can be defined with a negative sign. The similar way, when we are going to dealing with the advanced signal, advance is obviously going to identify with the positive sign. So you have to show a positive over here. So it should be z raised to 1. It is not written over here, this is a secondary story, but it is going to be defined as z raised to 1. And similar way, if you would like to show more than one particular advanced sample in the given signal, that many numbers of unit advance you have to connect in a series. Then and then you will be getting x, that many numbers of delay, sorry, that many numbers of advance into given particular signal. So x of n के बाद if we are going to in a series we will be having 3 to 4 different types of advanced symbols. Based on that, you can finally writing down a total signal as in y of n equal to x of n plus 2 or x of n plus 3, depending upon how many numbers of unit advance connected in a series, right? So these are the basic symbols which is going to be useful to define a particular system. So basically, if you have already gone through a control system with a block diagram representation of a system, the similar way, here I am going to show you at the end of this particular chapter that one particular system can be defined by different types of symbol which is going to be useful, and based on those particular symbols you have to writing down an equation. आप समझ रहे हो? Something like x of n मैंने लिखा, उसके बाद there will be a delay, after this there will be an advance, and after this there are another signal which is going to be using for the adder. Then it is going to be multiplying with some signal multiplier or constant multiplier. After these two particular signal will be multiplied, all and all, by taking all this into consideration, at the end you have to write down an equation for final output called y of n. And when you are supposed to writing down that particular equations, you have to keep in mind all this particular symbol will be used and how we are going to use those particular symbol to represent into mathematical way. If you know this, then and then you will be in a condition to writing down a final equations. So this is a prerequisite to writing down a final equation from this particular block diagram representation of a system. So whenever we are going to dealing with such type of example, at that time I'm one more time repeating these things, but you may please note down all these things, because this is useful to understand how we are going to figure out the mathematical representation from graphical representation. You understand, right? Now this is all about a discrete time systems. Now we will be having another topic called interconnection of discrete time system. When we are going to dealing with a different types of system, there might be possible that there are some interconnections happen in between. And what are those type of interconnection? Those interconnections are having a different categories. First is cascade or series interconnection, and this is quite logical. When we will be having 2 or 3 different systems and all those particular systems are connected in a series, how we are going to mathematically define this, how we are graphically define this, and at the end of these connections, what is the final output comes in a picture. So the first one is called cascade or a series interconnections. This is same as some basic electronic component we have connected in a series parallel. The same fundamental is going to be applied in the whole system as well. Second is a parallel interconnection, when two different systems are parallelly connected. And third one is a feedback interconnection. Now this is a quite well-known fundamental things. Okay, when we are having a system and a feedback will be given from output to input one more time, how it is going to be happen in terms of system. Now all these things you have already gone through, but those particular system will be a continuous. We are going to looking out the same concept of a series, parallel and feedback in a discrete time system. So you understand, जो कुछ भी हम इसमें पढ़ रहे हैं, this all basically related with the discrete time systems, which fundamental we have already gone through in a continuous time, right? Only different comes over here is a continuous time and a discrete time. But a majority of time some basic fundamental are remain same. but the mathematical representation and the way of expression is going to be changed because we are dealing with the discrete signal. And when we are going to dealing with the discrete system signals, we have to keep in mind we are dealing with the individual samples, right? So let us have a quick look on this. First is called a cascade or a series interconnections. Now this particular symbol is basically used for two systems when it is going to be connected in a series. Now you understand, if you are going to closely look at to this particular image or a block diagram, it can be defined as what x of n was the original input, will be given to the first system. Now T1 itself a system which is giving as an input over here. So x of n हमने दिया T1 में, and as a output of a first system, you will be getting first output system is called y of n. So it is quite logical. Okay, if I am going to graphically represent this input and output of a system, it can be defined as what y1 of n is the output of a first system, and those system is nothing but transformation 1 will be applied on x1 of n. So this is one system connected over here where input will be given as an x of n. So output can be defined as y1 of n is equal to T1 into x1 of n. Quite logical. Now that output of a first system will be given again as an input to the second. Why? Because both the systems are connected in a series. So T1 into x1 of n will be the input for T2, or you can say y1 of n is the input for T2. So as an output of T2, that can be defined as y of n, and y of n is nothing but T2 of yn, because y of n will be input in this case. And again y of n can be again defined as T1 into x1. So all in all, when two different systems are connected in a series, a final output can be defined as what? Y1, y of n equal to T2 into T1 into x1 of n. So now if you are going to looking at to this particular bracket representation, you easily understand that T2 is the main process which is having input as T1 into x1 of n, where T1 is again one more time process which is going to be applied on x1 of n. So all in all, you can understand when both the things are going to be considering in connected in a series, a final output can be defined as a multiplication of those particular all signals comes over here, right, in terms of input and output. Now by looking at this particular equation, the idea will be very clear. So let us identify this particular thing in terms of equation form. So the output of a first system. Now let us begin one more time from the beginning. That y1 of n over here, it is nothing but the transformation 1 T1 will be applied on x1. Now this particular thing, this output of a system 1 is going to be applied on a system 2, as we have already seen in the diagram. Let us understand the same thing by using equations over here. So T2 is the second process where your input will be y1 of n, and all in all the final output can be defined as y of n. So after connecting both the input signal T1 and input signal x of n, which is having two different system T1 and T2, by applying the T1 and T2 having one input called x1 of n, you can understand y of n equal to T2 into T1 of x1 of n, where x of n will be considering as your input, T2 and T1 will be two different system which is connected in a series. Similarly, we are going to having a quick look on parallel connections. So when we are having two system which is going to be connect in a parallel, we are going to understand that we will be having one system. So I think when we are going to having a block diagram, you will be having a better understanding over here. Now understand this. Now this is similar way, just looks like a adder symbol over here. But keep in mind, in adder we are going to adding two different signals. Now here we are going to adding two different output of a systems. So T1 and T2 are two independent signal systems which is having one common input x1 of n. So x1 of n will be again applied to T1 as well, and x of n will be again applied to T2 also. So two different system having common input. So obviously when we are having two different system, we will be having two different output as well. So y1 of n and y2 of n are the two independent signals or output signal which is coming from the system called T1 and T2, and both are connected in a series. Both are connected in a parallel, as you are going to looking at to this particular block diagram. So the final output y of n can be defined y1 of n plus y1 of n plus y2 of n. So you can understand, if we are going to talking about a connect, a series connection, the both the system will be considering as a multiplication of individual. When we are going to talking about a parallel, both the systems output will be coming as an addition of individuals, right? So now let us understand the parallel connection by using some mathematical equations. So quite simple, that output of a system 1 is will be considering as what, t1 into x1 of n, because x of n will be given as an input to t1. So ultimately the output can be defined as y1 of n, and output of a second system called y2 of n equal to nothing but t2 into x1 of x of n, because x of n was the original signal, will be again given to the second system as well. So y1 and y2 are the two different output of a different systems, and those are actually connected in a parallel, and that is why both are adding as a final output called y1 y of n. So y of n is nothing but addition of two independent systems output. So y of n equal to y1 of n plus y2 of n, where y1 is the first output systems and second y2 is the output of a second system. So all in all, you can define as y of n equal to t1 into x of n plus t2 n x of n. So in a simple meaning, when we will be having two independent system with a common input, the final output is nothing more than addition of two independent systems output. Right? Idea will be very clear by looking at the block diagram of parallel connections. Right. Third one is a feedback interconnections. So now feedback interconnections, it is logical thing where the output of any system that will be again given to the another systems through the error. So if you are going to looking at the block diagram, the idea is going to become very clear that x of n is one particular signal where t1 is one type of system. So this x of n will be again given as a t1, but the output will be considering as a y of n, but that output will be again giving as a feedback through one particular system called t2. So a combination of T2 with the output y of n as an input will be again giving as an adder. So all in all, by looking into this particular whole diagram, your final output y of n can be defined as T1 into the actually out, input into T1 is x1 of n plus the combination of this feedback part as well. So the final y of n can be defined as what, x of n plus T2 into y of n. So this is called a feedback interconnections. So whenever such type of series connection, parallel connection, or a feedback connections comes in a picture, we have to understand from the block diagram perception of the view that how we are going to be mathematically write it down, because the understanding of a graphical representation or a block diagram representation and try to convert that into a mathematical one, which is most important. Now our next topic we are going to be starting is property of a system. Now let me tell you, these are the extremely important thing. Here we are going to be list down a different types of system. Now we already have gone through a different type of signal. Now those all signals, and basically we are going to using a standard signal, something like unit step and unit ramp and unit exponential and impulse signal that will be given to the system, and after giving them to the systems, we have to identify the output based on that. Now it purely depends what type of output we will be getting, that it depends upon what type of system we will be having. So these are nothing more than a characterization of a system, and based on that system we have to identify which particular system it is. So we are taking one particular system, apply the input on that, and based on what type of output we will be having, we will be making comment on that particular type of system. That will be considering as a properties. So here we are going to be list down a few different important properties here. Out of those, first is called dynamic or a static system. So as I told you, if any system will be given to you and any input will be given to you, that particular input you have to apply to the system and check out its output. Based on whatever output you will be getting, you have to take a decision whether this given system is dynamic or a static. So you understand, each particular property having two types, but we have to identify which particular property is most suitable depending upon what type of input we have. So this is actually considering as a property of a system. And let me tell you, all these particular property having its own steps to checking out whether given system is dynamic or static, or given system is either this or this. So each individual system you have to understand thoroughly how we are going to be checking out its property, that is most important. So here we are having a list of property. Out of those, first is dynamic and static, second is time variance property, third is linearity property, fourth is causality property, and fifth is stability property. Now stability property we already have gone through. A stability property is nothing but we have to identify whether given system is stable or unstable. Similar way, causality property, where we have to check it out whether given system is causal or non-causal. Similar way, in a linearity property, we have to check it out whether given system is linear or non-linear. Time variance property, where we have to check it out whether given system is time variance or time invariance. In similar way with the dynamic and static system as well. So we will be having a look one at this particular property one by one, but each individual property having its own examples as well. So first I am going to taking one particular property of a system, explain into a detail how we are going to checking out whether given system is dynamic or static or a time variant or invariant, and then I'm going to give you as an assignment for 5 to 10 examples to checking out an individual property. Now to understand this particular property, which type of property we are having, you have to be very clear about all these particular operations, something like time shifting operation and time scaling operations, because majority of time you have to understand these things by calculating some mathematical properties of different type of system and signal whatever going to be applied. So let us start with the first called dynamic and static system. So this is also, considering as a dynamicity property. Now these all properties are of systems. So if any system will be given to you, we have to check it out, okay, whether this particular system is dynamic or a static. And that is also considering as a dynamicity property. So the first thing you need to understand over here is what, when system is called static and when system is called dynamic. So let us understand it by the technical definitions. So technical definition says a static system, a system in which the output at any instant of time depends on input sample at the same time. Now read it one more time and try to identify what type of system static is. So static is a system in which the output at any instant of time means what? Output hoga y of n, which is depending upon only and only input sample. So to understand this particular dynamic or a static or a dynamicity property, let me tell you y of n or whatever going to be written at the left side will be majority of time considering as an output, and majority of time y of n will be considering as an output. This is a predefined symbolic representation. So y of n, which is actually representation as an left side called y of n equal to 5 into x of n. So whatever written on a left side, a left side of an equal to sign will be considering as an output, a symbolic representation or a notation for the output, and right side whatever we are going to writing down, that will be considering as an input notations. But all in all, when we are going to be dealing with the symbolic or notations, denotations of y of n will be majority of time useful as an output, and x of n will be useful for the input. In our case, we are going to be dealing with this type of fixed notations. There might be changes during the examination, that might, you understand, but you have to keep in mind whatever written on a left side will be denoted as an output, whatever written on the right side will be denoted as an input. By looking at the equation, you might be getting an idea, okay, what is the input and what is output. So static system is the system where the output, so output in this particular case is y of n. So y of n will be depending upon only the input system at the same time. So so here are some of the example. You can understand y of n equal to 5 into x of n. So y of n is the output which is depending upon the input at the same time. So same time or the input simple at the same time. For that we are having one more word called present input. Means what? Y of n है तो यहाँ पे x of n ही होना चाहिए. That is called a present input. So now to understand this terminology, we will be having total three important aspects. You may please note down. Present input is, simple present input. Y of n के सामने x of n होना चाहिए. That is going to be decided as a present input. Now another terminology we are having, that is considering as the past input. Now past input is nothing more than a delayed input. So whenever delay comes in a picture, that is known as a past input. And we already know delay signal can be defined with the negative sign. So अगर यहाँ पे ऐसा लिखा होगा कि 5 into x of n minus 1, so x minus 1 is known as delayed signal, and for that we are having terminology called past input. One more time, present input means what? Y of n equal to x of n. It is going to be depending upon the same input at the same time, known as present input. Delayed signal can be defined as past input, and when we are going to dealing with an advanced signal, it is denoted as future input. So three terminology you have to understand very carefully: present input, past input, and future input. Present input means what? Input at the same time. Past input means the input of a delayed signal, and future is nothing more than an advanced signal. You may please note down one more time. Present input means what? Input at the same time. Past input means input with somewhat of delayed signal, and future means advanced signal. So static signal can be defined as the output is depending upon only and only present, not on past, not on future. So in a simple word, if somewhat of signal given something like over here y of n equal to 5 into x of n, you have to look at this. Okay, is there any delay signal? Is there any future signal? No. यहाँ पे कोई पास्ट नहीं है, कोई फ्यूचर नहीं है. नो डिलेड सिग्नल, नो एडवांस सिग्नल. इट इज प्योरली डिपेंडिंग अपॉन अ प्रेजेंट इनपुट. That is why this particular system is called static system. Looking at over here, y of n equal to x square of n plus 5 into x of n plus 10. Now future means what? Future signal means अगर मैं n की जगह पे यहाँ पे 1 रखूँ, तो x का भी इनपुट 1 में ही हमें मिलना चाहिए. अगर ये 1 रखने के बाद अगर x का इनपुट 3 या 4 हो जाता है, सो दैट विल बी डिपेंड कंसिडरिंग एज अ फ्यूचर इनपुट. सो लेकिन यहाँ पे मेजोरिटी ऑफ पीपल विल बी कंफ्यूज दैट एक्स स्क्वायर ऑफ एन है. तो आप यहाँ पे एक बार चेक करके देख लो. If you are going to put y equal to 1, n equal to 1 over here, that will be decided as y of 1 equal to x square of 1. So x के bracket में it is going to be remain 1 only. Now instead of this अगर x of n square होता, then it will be considering as an future signal. So do not be confused. The simple one thing you have to keep in mind, okay, if in a system, if there is no delay or no advance, no past or no future signal, it is purely depending only and only on the present input, system is called static. So is that clear about static system? Static system is a system which is purely depending upon a present input, not on future, not on past signal, right? So I mean opposite of this will be considering as a dynamic system. So let us read this particular definition one more time. Dynamic system is the system in which the output at any instant of time depends on input sample at the same time as well as at the other times also. Now here the other time means, as I explained earlier, other time means it is depends upon past and future time also. And past is nothing but delay signal, and future is nothing but the advance signal. Means a dynamic systems is the system where the output will depends upon present, past, or on a future signal. So if you are going to look at the example, it is very clear that y of n equal to x of n plus 5 into x n minus 1. So now if you are going to observe this carefully, यहाँ पे आप देख सकते हो x of n minus 1, it is nothing more than a delay signal. So we can consider this is as a past signal. So by looking at to this particular whole equation, you can understand these particular signals output will depending upon the past input as well as, that is why it is goes into a category of a dynamic system. If there is no past, then it will be goes into category of static system. So simple. By looking at the equation, if you can find out any delay signal or any advance signal, that will be considering as a dynamic system. Looking at the second example as well, y of n equal to 3 into x of n plus 2 plus x of n. Now at the first term, you can understand x of n plus 2 is nothing but the advanced signal. So when it is considering as an advance, it is called a future signals. So where the output is depending upon a future system is called dynamic. So one more time, let me explain about static and dynamic is the output of any system is depending upon only and only present, not on future, not on past. Signal is system is called static, where the system's output is depending upon present as well as on past or future, then it is called a dynamic system. So in a simple technical meaning, by looking at the equation, if you can finding out any advance or any delay signal, it is considering as this particular signal will be defined as dynamic system. Now here there are some of the examples given to you, and this will be considering as an assignment. You have to understand carefully. Looking out the equations, note down whether it is going to be depending upon present, past or future, and based on that you have to identify which type of system it is, whether it is static or dynamic. You may try these at your home and we are going to solve any of your doubt in the next lecture. Thank you.